I'm Colin Vandeldin.
And I'm Fedor Dolgachev.
We are seniors at Skyline High School in Ann Arbor, Michigan.
CNC machining is a commonly used subtractive manufacturing technique that is used to make parts out of a variety of materials, ranging from softwoods to hard metals. There are two primary types of CNC machining. One in which a rotating cutting tool is used, which is fed through material, which is an example of which is shown in this video. The other is where there's rotating material and a tool is fed through it. Figuring out how fast to rotate the tool or the material and how fast to move the tool through the material is something that is often quite challenging. And with traditional methods, it requires hours of testing or years of experience with the specific machine that is being used, the specific material that is being cut, and the specific cutting tools that are being utilized. Because of this, software has been developed to make this process faster. However, based on my experiences and the experiences of other people that I've talked to, existing software either lacks capability or produces results that are not usable, or it is simply too hard to use. Often a combination of all three, which is why we were motivated to create a better piece of software.
When we first began software development, we needed to figure out what language to write our program in. We decided on JavaFX because it has support for a graphical user interface and because we were already familiar with the Java language. We then got to work on creating a class hierarchy, which we then based the rest of our project on. Our first milestone was when we had just 3 boxes with inputs and outputs for the user. We then scaled this up to have many more boxes and for both inputs and outputs. We also created a visual aid software that allows the CNC machinist to get an idea of what the cut will look like. We then combined both the calculator portion and the visual aid portion into a project and then developed that slightly further to get the final result, which is shown here.
After we got this result, we decided to test our software against an existing piece of software. We did this by gathering some basic cutting data and inputting it into our software and the existing piece of software. We then took the results from our software and the existing piece of software, and we fed those into a program which can generate code which a CNC machine can use. We then took the program outputted by the programming software and loaded it into an actual CNC machine and did some test cuts in some 6061 aluminum. We then analyzed the results. And the results showed that in a majority of situations that we tested, our software either provides legitimately useful results or results that are more efficient.
We hope that our software gives CNC machinists the tools that they need to have both safer and speedier cuts.
Without hours of testing. Okay, that was good. That was cash money.